Hello everyone, welcome to Dakshana e-classroom program, and this is a solution video for paper MZT01 for NEET part physics. So I hope everyone tried their best during your exam, and I hope this video will be helpful to you in clearing your doubt of the questions which you were not able to solve during your exams. Let's continue without any delay, and I hope everyone is having your paper also. So I'm going just question one by one in sequence, not going to write down the question here. So here we have question number 1. It's in the circuit in following figure the value of y. So यहाँ पे आपको 3 गेट दे रखे हैं, G1, G2, G3, all are NAND gate. So here we can talk about start from actually gate 3. So in gate 3 both input are like initial inputs, it's 1, then inverse of NOT gate, so it's 0, so 0 0, then inverse of that it will be like 1 output. So here question number 1. So this is gate 1, like the way it's given. This is and this, let me just draw the diagram here. This is 1, and here both are given same input, this, and this is okay, all right, and this is output y. So now what is happening? This is 1 in NOT, so it's 0 0 0, then it will be like 0, but inverse of that, so it's 1 here. So 1 is fed here 1, and this one is also 0, so 1 0, then its output will be like because it's AND gate, it's 1, inverse of that it will be 0 here, so it's fine. Just AND gate, sorry, NAND gate, so it's 0 comma 1, then output will be 0, and then inverse of that it will be 1 here, 1, and here see 1, so NOT gate 0, again NOT gate, it's 1, so 1 and 1, so we will get here AND gate up to here we will get 1, inverse of that we will get 0, so output y is coming out to be 0, which is matching with option number 1. So correct answer is 1. Question number 2. The circuit has two oppositely connected ideal diode in parallel. Which of the following current which is the current, what is the current flowing in the circuit? तो यहाँ पे आप देख सकते हैं like D1 is reverse bias, D2 is forward bias, D2, तो D1 क्या हो गया, सीधा सीधा कैंसिल हो जाएगा, net voltage is 12 and net resistance will be 4 plus 2 6, so current will be I is equal to simply 12 divided by 6, that's equal to 2 ampere, matching with option number 2.0. Next question number 3. So here a radioactive nuclei decay as follow: X going to alpha, X1 going to beta, then X2 going to alpha, then X3 and going to gamma, then X4. So here we have actually like 1 2 and here 2 alpha. So initially it's given as A Z, so A is equal to 180, Z is equal to 72. So let's calculate the final atomic weight and atomic number of element Z, X4. So for that I can write Z for final element for X4, so I can write that Z will be equal to 180 minus, because in beta there is no change in atomic weight, in gamma also there is no change, so in every alpha there will be change of 4, so this minus 2 multiplied by 4, that's coming out to be 172 will be the atomic weight, sorry it's A actually, and Z will be equal to how much? In each alpha it will decrease by 2, each beta it will increase by 1, gamma no change, so it's basically 72 minus 2 into 2 plus 1, that's 68 69. So the right answer matching with 172 comma 169, that's matching with option number 3. Next question number 4. If m is the mass of the electron, v its velocity, r is the radius of the stationary circuit orbit around a nucleus with the charge Ze, then from Bohr's first postulate, the speed u of the electron in CGS system in orbit is given by, so it's simply like mv square by r is equal to 1 by 4 pi epsilon naught into Ze square by r square. This is the relation. R is the radius, so one r gets cancelled, and m, yeah, here it's basically speed, and this value of k in CGS system is equal to unity, so it's simply Ze square by r divided by mass m root over this will be your u, and that's matching with option number 2. Next question number 5. So when a radiation is incident on a photoelectron emitter, the stopping potential is found to be 9 volt. If E by m ratio of the electron is given to you, this the maximum velocity of the ejected electron. So stopping potential तो अपन को पता है, maximum velocity means half mv square. Kinetic energy is equal to stopping potential or E into V stopping potential. So यहाँ पे आपको V maximum पूछा गया, so V will be equal to E Vs multiplied by 2 divided by m root over this. E by m is given, so substituting and solving we get the answer. It's coming out to be 1.8 into 10 to the power 6 meter per second, matching with option number 3. Next question number 6. The first diffraction minimum due to a single slit diffraction is at theta equal to 30 degree for a light of wavelength 500, the width of the slit. So यहाँ पे first diffraction minima, we know actually the condition is sin theta is equal to lambda by a. Lambda is given, theta is given, just a is equal to lambda by sin theta, everything is given to you. 30 degree, lambda is, substituting and solving we get a is coming out to be 1 into 10 to the power minus 4 centimeter, matching with option number 2. Next question number 7. So in Young's double slit experiment, the intensity at the central maxima is observed to be I naught. If one of the slit is covered, then intensity at the central maxima will become, if one of the slit is covered, then intensity at central maxima will be equal to intensity of one slit, because only one is left. And we know the relation between net intensity I net is equal to 4 times of I single, I1, and this is given as actually I naught. So I1 is equal to simply I naught by 4. That is the answer, matching with option number 3. Next question number 8. A person wishes to distinguish between two pillars located at a distance of 11 km. What should be the minimum distance between these pillars? So that's basically a resolving power of human eye based problem. So we know a human eye based have a resolving power of 1 minute in angle, and that's equal to basically 1 by 60 degree, and this is 1 by 60 into degree, it's 180 that's degree, it's converting to pi by 180, and this is the angle, and that is equal to what? D divided by this 11 kilometer. This is the relation. Solving we get D is equal to actually this is a 3 meter, matching with option number 2. Next question number 9. Equi-Convex lens has a focal length f and power p total. If is cut into two symmetrical half by a plane normal to the principal axis as shown in the figure, the two pieces are recombined as shown in figure. So combined total length, focal length, power p. If it is cut half, then its focal length become 2f, focal length 2f, and power will become p by 2, p by 2. Now they are placed like this, just in this orientation. So power will be p by 2, power will be p by 2, and net power is equal to p1 plus p2, that's equal to p by 2 plus p by 2, that's equal to p. So that is the answer, matching with option number 3. Next question number 10. A point object is placed at a distance of 10 centimeter from its 10 centimeter, and its real image is formed at a distance of 20 centimeter from the concave mirror. Okay, so u is given, v is given. If the object is moved by 0.1 centimeter towards the mirror, image will shift by about. So we know actually delta v is equal to minus v square by u square into delta u. Delta u is given as plus 0.1 because it's moving toward 0.1 centimeter. V is 20 centimeter, U is 10 centimeter, so delta V is equal to minus, this is minus 20 by minus 10 whole square into 0.1, that's coming out to be minus 0.4 centimeter. So delta V, and minus means it is implying moving away, because it's moving towards, then it will be plus. So 0.4 centimeter away from the mirror, matching with option number 1. Next question number 11. So here we have the average power consumed by the given circuit is. तो यहाँ पे आपको दिया गया है सर्किट दे रखा है R L C, right, and the power source battery is given. So we can get R is equal to simply 3000 ohm, and L is given, omega is given as 300 actually. So L is equal to how much? XL is equal to omega into L, 3 gets cancel, it's 5000, and C, XC is equal to 1 by C into omega, so that's coming out to be micro. It's also equal to 5000 also. So XC, with substituting the values, X is equal to 1 by omega 300 into 10 by 3 into 10 to the power minus 6, so 10 to the power 6. This and 3 gets cancelled, this, so it's basically 1000 ohm. So net Z is equal to root over this square, this minus this square, so 300 square plus 3000 square plus 4000 square, that's coming out to be 5000. So this is your ohm is the Z. Now what it's asking basically, average power consumed. So average power consumed is equal to P average is equal to V square by Z square multiplied by R. Substituting everything and solving, we get it's coming out to be basically 4.8 watt. That is the answer, matching with option number 2 for question number 11. Let's see the next question number 12. Let me erase the board first. Okay, so next question number 12. A laser beam is of 9 milliwatt power, diameter 2 mm. What is the amplitude of magnetic field associated with it? So question number 12. तो यहाँ पे आपको power दे रखा है, that's 9 milliwatt, and diameter is given as 2 mm. So now what is the relation basically? So basically power, we can intensity equal to power by area divided by C is basically energy density, that's B square by 2 mu naught, and this can be right power, it's 9 milliwatt minus 3 divided by area, this is pi into D square into 4 into C, speed of light. Substituting everything and solving it, we get B naught is equal to 4.9 micro Tesla. That is the answer, matching with option number 4. Question number 13. Rod of length 20 centimeter is rotating with angular speed of 100 revolution per second in a magnetic field of strength 0.5 Tesla about its one end. What is the potential difference between two ends of the rod? So it's simplest straightforward question. B is equal to this is velocity. Potential difference is equal to B omega into L square by 2. So substituting, B is given as 0.5 Tesla, omega is given. Substituting and solving everything, we get EMF is equal to 6.28 volt, matching with option number 3. Next question number 14. A bar magnet of pole strength is given as 2 ampere meter of 4 centimeter length placed in a uniform field of 5 Tesla, such that the its magnetic equator makes 60 degree along with the field direction, then torque on the magnet. So tau is equal to m bar cross b bar, and m is equal to pole strength, that is equal to 2 multiplied by 4 into 10 to the power minus 2. This is the smaller means capital M. B is given, and the theta angle between them is equal to 30 degree. Substituting and solving, we get tau is equal to 0.2 Newton meter, matching with option number 1. Question number 15. So रैंक द वैल्यू ऑफ इंटीग्रल b डॉट डी एल फॉर द क्लोज्ड पाथ शोन इन द फिगर। तो यहाँ पे आपको अलग अलग पाथ्स दे रखे हैं, दिस एंड हियर इट्स 2 ampere, 2 ampere, and this is 3 ampere, this. So one is covering this, another consisting of this, another consisting of this. So this is A, this is B, this is C, this is D. So integral b dot dl is equal to mu naught into I enclosed. So for A, integral b dot dl for A, it will be equal to A, we check it, coming out to be 0. For B, it's equal to, let me write outward as positive, so it's basically 5. And for C, it's 1, and D, it's basically cancel 3. So now we figure smallest to largest. So smallest A, C, D, B. A, C, D, B, that's matching with option number 2. Question number 16. The magnetic field due to a straight conductor of uniform cross section of radius A carrying a steady current is represented by. तो यहाँ पे cylindrical conductor है, and we know inside B is directly proportional to R, outside B is inversely proportional to R, and from here the graph is like this and this, which is matching with option number 1. So 16, answer is 1. Next question number 17. Galvanometer resistance 50 ohm is connected to a battery of 3 volt along with the resistance of 2950 ohm in series. A full scale deflection of 30 division is obtained in the galvanometer. In order to reduce this deflection to 20 division, the resistance in series should be. तो यहाँ पे क्या हो गया? Let's say the unit of 1 division, that's equal to x. So I can write 30 division means 30x is equal to voltage divided by total resistance, that is equal to 50 plus 2950. Next case it's 20 division, so 20x, this is equal to 3 divided by 50 plus x. From these two equations, just simply dividing and solve. Let me write it, this is R. Dividing and solving, we are getting R is equal to 4450 ohm. This is the answer matching with option number 2. So next question number 18. The current density at a point is given by J is equal to 2 into 10 to the power 4 J cap ampere per meter square. Find the rate of charge flow through a cross section of area. Rate of charge flow means current. So current I is equal to J bar dot S bar or area vector, and everything is given. So it's 2 into 10 to the power 4 J cap dot product. So it will be like 2 I cap 3 j cap, so it's 3 j cap because j dot j will be equal to 1, so it's coming out of 6 into 10 to the power 4 and centimeter square, so this will be gone, and that's coming out to be 6 ampere. This is the current matching with option number 4. Question number 19. During charging of capacitor, find the time when potential drop across capacitor equal to potential drop across resistance. Potential drop across resistance is equal to V naught e raised to minus t by tau, means RC. This is also equal to potential drop across capacitor is equal to V naught 1 minus e raised to t by tau. This. And solving and substituting it, तो यहाँ पे आपको V naught gets cancelled. We need to simplify it for time. Simplifying it, so we are getting a T is equal to RC ln 2 is the answer matching with option number 3. Question number 20. Two metal plates having potential difference of 800 volt are 2 centimeter apart. It is found that a particle of mass 1.96 into 10 to the power minus 15 kg remains suspended in the region between the plates. The charge on the particle will be. तो यहाँ पे मतलब mg force is balanced by q into E. E will be equal to Q multiplied by E is V divided by D. So Q is equal to mg into D divided by V. M is 1.96 into 10 to the power minus 15. G is 10 divided by voltage, that is 800 multiplied by this is 2 centimeter 10 to the power minus 2. Solving it, it comes out to be Q is equal to roughly 3 times charge of an electron, matching with option number 1. Next question number 21. A point charge Q1 exert a force F upon another point charge Q2. Okay, if a third charge Q3 be placed quite close to the charge Q2, then the force that Q1 exert on the charge Q2 will be, so it will still remain same, because by principle of superposition the force between two charged particles is not influenced by the presence of another charged particle, but net force will be definitely influenced. So here the right answer will be matching with option number 1. Question number 22. Three concentric metallic spherical cells of radii r, 2r, 3r are given charges this q1, q2, q3 respectively. It is found that the surface charge densities on the outer surface of the cells are equal, then the ratio of the charges given to cell q1, q2 and q3. तो यहाँ पे अपने पास 3 cell this so इसको charge q1, इसको charge q2, this को charge q3. So this charge will appear on its outer surface. Charge on this surface will be like plus q1, here it will be minus q1. Charge on this will be plus q2 plus this, and this is minus q1 minus q2. So charge density will be this divided by 4 pi into 3r whole square, and here charge density divided by 4 pi into 2r whole square. Here charge density divided by 4 pi into r square. All these charge densities are equal. Equating them and simplifying and writing everything q2 and q3 in terms of q1, then we will simply get the ratio of q1 is to q2 is to q3. That's coming out to 1 is to 3 is to 5, matching with option number 2. So next question number 23. Siren placed at railway platform is emitting sound of frequency 5 kilohertz. A passenger sitting in the moving train A record a frequency of 5.5 kilohertz while the train approaches the siren. Okay, so approaching, so means it's 5.5 kilohertz is equal to original frequency f naught. This is observer is approaching, so it's v plus v1 divided by v. Okay, that is the during his return journey to a different train B, he recorded a frequency of let's say 6 kilohertz while approaching the same siren. The ratio of the velocity of train B. Okay, so in next case it's 6, it's 5, and it's v plus v2 divided by v. So you're asked to find the ratio of v2 by v1. Just simply basically from here we can simplifying it, we can get the value of v, substitute it here and solve it in terms of v1 and v2. Simplifying it, we get v2 by v1 is equal to 2 simply, matching with option number 2 also. Question number 24. Length of the wire shown in the figure between pulleys is 1.5 meter and its mass is 12 gram. The frequency of the vibration with which the wire vibrate in the loops forming antinode at the midpoint of the wire is. So frequency पूछी गई है. So frequency will be equal to nu will be equal to v by lambda. Velocity v is equal to root over t by mu. Tension is given as 9 kg, so 9 g. Mu linear mass density, mass is given, length is given, and we are given actually 3 lambda by 2 is equal to 1.5. This implies lambda is equal to 1 meter. So everything is given. So nu frequency is equal to, this is 1 by 1 into root over t, that is 9 into g, divided by mu, that is mass 12 into 10 to the power minus 3 into gram, that's length 1.5. Simplifying it, we get nu frequency is coming out to be 105 hertz, which is not matching with any option. Right answer is 4th. Next question number 25. So here particle is moving with constant angular velocity omega along the circular path of radius a as shown in the figure. Find the x component of the velocity of the particle as function of time. तो यहाँ पर है इस तरह का system. So initially this is given as some 30 degree and particle is moving in this manner. So at some time, let's say this is omega t, particle is here, this. So now we can, this theta will be omega t plus 30, so this will be also same, this will be also same. So x component will be like this is a omega into minus cos of omega t plus 30. So that's matching with option number 3. That is up to question number 25. Let me erase the board and we will discuss the question number 26. Okay, next question number 26. Gas is found to obey P2V equal to constant the initial temperature and volume of the gas at T0 V0. If the gas expands to final volume 3 V0, find the final temperature. So question number 26, it's P square into V is constant. This is the way. PV equal to nRT. So P is equal to T by V. Substituting it here, T square by V square into V. That's equal to T square by V equal to constant. That initial temperature T0 V0. So T0 square by V0 equal to final temperature T final divided by 3 V0. Cancel. This implies T final is equal to root 3 into T0. That's matching with option number 2. Next question number 27. So a pressure P, absolute temperature T diagram was obtained when a given mass of gas was heated during the heating process from state 1 to the volume. तो यहाँ पे आपको process दिया गया है. This is process 1 to 2 and this is P versus T diagram. For this we know actually this is the slope, and so this process is constant volume. And here we know actually the slope is inversely proportional to volume. Initially the slope is high, so means volume is low, so final volume will be V1, V2, so this is higher, so means volume is increasing. That's matching with option number 3. Question number 28. Raft of wood of density 600 kg per meter cube of mass 120 kg float in water. How much weight can be put on the raft to make it just sink actually? तो इसका वॉल्यूम कितना हो जाएगा? So volume is equal to basically mass upon density, that is equal to 120 kg divided by 600, that's equal to 0.2 meter cube, and this is the volume. So if it is sinking completely, how much weight of water it can displace? So weight of water displaced, that's equal to density multiplied by density volume multiplied by density of water. So this is coming out to 200 kg. So this much volume it will displace, this much weight can be like placed including the weight of the raft. So already 120 kg is there, so 80 kg additionally can be put. That's matching with option number 4. Question number 29. Two wires of same length and material but different radii R1 R2 are suspended from the rigid support. Both carry the same load at the lower end. The ratio of the stress developed in the second wire to that in the, so stress is equal to weight mg divided by area, that is mg divided by pi r square. So inversely proportional, and sigma 2 by sigma 1 is equal to mg is remaining same, this is r1 square by r2 square, matching with option number 2. Question number 30. Potential energy of 2 kg body at the surface of the planet is minus 100 joule. Escape velocity, so means escape velocity, the net energy must be equal to 0. So the potential energy minus 100 should be equal to mv square by 2, and mass is given as 2 gets cancelled. This implies v escape is equal to 10 meter per second, matching with option number 1. Next question number 31. Keeping the mass of the earth to be constant and its radius is half, then duration of the day, so angular velocity will change to keep the angular momentum constant. So we can apply I1 omega 1 equal to I2 omega 2, and I is 2 by 5 m r square into omega can be written as 2 pi by T1. Next 2 by 5 into m, mass remaining same, r by 2 whole square multiplied by 2 pi by T2. This implies T2 is equal to T by 4, that's equal to 6 hour, matching with option number 4. Question number, so the duration of the day will become 6 hours, matching with option number 4. Next question number 32. Consider a uniform square plate of side A and mass m. The moment of inertia of this plate about an axis perpendicular to its plane and passing through one of its corner is. So about this, so it's ICM. I about this is equal to ICM plus this A by root 2. So m into A by root 2 whole square. ICM is m A square by 6 plus m A square by 2. Substituting, solving it, it's coming out to be 2 by 3 m A square, matching with option number 3. Next, question number 33. The body of mass m moving with velocity v along a frictionless horizontal track and another body of mass m by 2 moving with the 2v collide with the first body. Elastically find the speed of the first body. It's simple collision based problem. तो यहाँ पे आपको दो, this is m, velocity v, another body mass m by 2, velocity 2v. So this is 1, this is 2, this is u1, u2. So we know v1 is equal to m1 minus m2 by m1 plus m2. This is formula u1. This is m2 2 divided by m1 plus m2 into u2. Simply substituting and solving, we get v1 is coming out to be minus v meter per second. So the answer matching with, it's just talking about the magnitude, matching with option number 2. Next, question number 34. So a coin placed on a rotating turntable, just slide if placed at a distance of 4 centimeters from the center. If the angular velocity of the turntable is half, it will just slip. So means here, like friction force, mu g is balancing the r omega square centripetal force. So initially, and then later on, angular velocity of the turntable is half. So mu g is remaining same. So mu g will be equal to r prime into omega. Angular velocity is half square. This implies r prime is equal to 4r, that is equal to, initially it was 4 centimeters, so it's now 16 centimeters, matching with option number D, 4. Question number 35. Body moved along a straight line by a machine delivering a constant power. The distance moved by the body in time t is proportional to constant power. Power is equal to force multiplied by velocity, that is equal to some constant. This is equal to mv dv by dt is equal to constant. So this implies v square is directly proportional to t, v is proportional to t root 2. V can be written as ds by dt. This integrating again, so this implies s is directly proportional to t power 3 by 2. That's matching with option number 2. Question number 36. Delivery man moved 10 carton from sidewalk along 10-meter ramp to a loading dock which is 1.5 meter above the sidewalk. If each carton has a mass of 25 kg, what is the total work done by the delivery man on the carton to move them to the, so that is equal to change in potential energy. So m mass is 25 kg, g h 1.5 into total carton 10. This is the work done, solving, it's coming out to be 3750 joule, matching with option number 2. Question number 37. In the arrangement shown, the frictional force on 2 kg block is, so here this is the system, frictional force 2 kg block, this, and this is 1 kg block. So now downward force, this is 30 degree, 2g sine 30 degree. Upward force tension, that is equal to weight of this, so T is equal to 10 Newton. Let me calculate this, how much, so 2 into g, 10 into sine 31 by 2, that's also equal to 10 Newton. So means this is actually balanced, no need for any frictional force, so frictional force acting is 0, matching with option number 3. Next, question number 38. Okay, a mass m1 hanging at end of the string, draw a mass m2 along the surface of the smooth table. If the mass on the table be double, the tension of the string become 1.5 times then the m1 by m2. Okay, if mass on the table is double, so we know actually A is equal to pulling force m1g divided by m1 plus m2, then T is equal to m1 m2 into g divided by m1 plus m2. So initial tension is this, later on m2 is becoming 2m, so then tension is becoming 1.5 T. This is m1 into 1.5 m2 into 2m2 multiplied by g divided by m1 plus 2m2. Just simply dividing and solving, we get it basically m2 by m1 by m2 equal to 2 is to 1, matching with option number 1. Question number 39. If radius of a spherical bubble start to increase with the time t as r is equal to 0.5 t, what is the rate of change of volume of the bubble at t equal to? So volume of the bubble is 4 by 3 pi r cube. So this is rate of change of dv by dt equal to 4 by 3 pi into 3 r square into dr by dt. 3 gets cancelled, 4 pi at r is t equal to 4 second, r is equal to how much? 2. Substituting and solving this, because everything is given to us, we are getting this is coming out to be 8 pi units per second, matching with option number 1. Next question number 40. Let me raise the board again. Okay, so next question number 40. So a particle start from rest from point P and follow a path PQ on the three surfaces shown in the figure. If time taken by the particle in these cases as T1, T2, T3, then select incorrect statement. So question number 40. So this is the situation, this is H, this is X, this is let's say theta, K is 1. So it can be written as X sin theta is equal to H, so X is equal to H by sin theta, and this is the X. Acceleration will be equal to g sin theta, time is equal to 2 root over 2x by g sin theta, that is equal to root over 2h by g sin square theta. So in every case 2h is constant, g is constant, theta is different, so we can definitely write incorrect statement. We need to check T1 equal to T2 will not be equal to T3, so sorry, answer will be matching with option number 3. Simply directly we can write. Question number 41. Physical quantity x is given by this expression, the percentage error in the measurement of this is equal to this, then the rest. Okay, this can be solved by taking the log. So this log and differentiating delta x by x is equal to, this is 2 times delta k by k plus 2 times delta l by l plus this is delta m by m plus half times delta n by n. Everything is given. This delta k in percentage, this is given as 2 into 1 plus 2 into 2 plus this is 3 plus 4 by 2. Solving, it's coming out to be 11%. That is the answer, matching with option number 4. Question number 42. The power P of machine is given as function of time P is equal to A t power minus 2 plus B t power minus 3 plus C then time. So this is also power, this is also power, this is also power. So C is simply power, B is equal to power into t power 3 plus, and A is equal to power into t power 2 plus. Now the value of A into B by C, substituting and simplifying it, we get it, it's coming out to be m1 l square into t minus 2 is the right answer. So one second, what happened here? Power creating some trouble. Okay, just 42, 3 more questions. Question number 43. If sum of the two vectors in sum of two unit vectors is a unit vector, then the magnitude of their difference is. So Sum of two unit vector is a unit root over, this is 1 square plus 1 square plus 2 into 1 into 1 into cos theta. This is equal to 1. Solving, we get theta is equal to 120 degree. Then difference is equal to root over, this is okay, so it's a plus b, angle is okay, then a minus b. So this is again 1 square plus 1 square plus 2 into 1 into 1 into cos of 60 degree. It will be 180 minus 60 degree. Solving, it's coming out to be root 3. So that is the answer, matching with option number 2. Question number 44. Surface area of the cube is changing at the rate of 5 meter square per second. Find the rate of change of polydiagonal at the moment. Okay, so surface area of the cube is equal to 6a square, and this is equal to dA by dt is equal to 12 into dA by dt. This is given as 5, so this is equal to 5 by 12 dA by dt. Body diagonal is equal to root 3 into this, so d by dt of this is equal to root 3 multiplied by dA by dt, that is equal to 5 into root 3 by 12, that is 5 by 4 root 3, matching with option number 4. So this is all about your paper number 1 for MJT01. I hope this video is helpful to you in clearing your doubt and understanding. Thank you.